and flows describe the changes over time or the processes that are currently going on in a city. So my colleagues always operate with this terminology, stocks and flows. And as geomatics people, we have to get involved in stocks and flows. A city model would be the stock, okay, and the change or the updating of a city model would be the flow part of the business. Now, this is quite important. This describes our overall projects, stocks and flows of people, of energy, of water, of materials, of capital, of space, and of information. So these are our 1, 2, 3, 4, 5, 6, 7, 8 modules, research modules on the project. And I myself, I work as a PI for the information simulation platform, which is on the lower part. The simulation platform is a platform where all the data from the other modules are coming together and are being collected, analyzed, processed. Okay? So this simulation platform is different components, GIS software, visualization software, and so forth, and so forth. And we are defining 3 different scales in our work: the small lab, the medium lab, and the large lab. So large lab would relate to territorial scale, medium lab to urban design or to, let's say, to a neighborhood, whereas the small lab would refer to individual house. I just give you an example because we are also involved in other projects. So for instance, this is a hotel in Switzerland, a new one at 3,000 meter altitude. The Monte Rosa, run by the Swiss Alpine Club. It accepts about more than 200 people per night. And it's 95% self-sufficient. 95%. See, this is all sun panel. So it lives from sun energy. And all the waste, only 5% of the waste goes out. The waste that humans are producing. 95% is processed and reused internally. This is at 3,000 meter, and if you come to Switzerland, I can recommend it to you, but not in winter time, because you have to walk there long distance, and it's next to a glacier, as you can see. It's actually closed in winter because it's too harsh. But in summertime, it's really interesting thing. So this would be an object of SLab. We also work in Masdar City in Abu Dhabi. There's a part of Masdar City which is called Swiss Village. So this would be typically M scale. And a new town, a small town, is being built now, planned now in Ethiopia, which would define the large lab case. So these are projects which are either finished already or ongoing, and they show the scale that we are involved in. And we are also involved not only in Singapore, but we are using data from other cities all over the world. Most of them are megapolis, very large cities, mega cities, as you can see here. So, simulation platform, I think you all know what simulation is, but in order to do simulation, we have to get data, okay? So data acquisition is very important, and simulations are being done in architecture, in urban planning, for different purposes, different goals. And our visualization platform is called Value Lab Asia. This is an advanced interactive urban simulation environment, which I will show you later, sorry. The simulation platform itself has a number of jobs to do, like generation of digital surface models from different kind of data, further development of techniques for 3D city model generation, bring it to a higher level of automation. I mentioned a powerful visualization platform. We have already set up a GIS, and we are working in research on 3D, 4D capabilities. The whole thing I should mention is not related to teaching, really. This is all a research project for ongoing for 5 years. So we have to investigate into change detection and the updating of databases. We are working with reality-based data, but also with generic models. We have to handle dynamic and semantic aspects that leads to the notion of 4D city models. 4D denotes, the fourth dimension denotes the change over time or ongoing processes currently. People also look into location-based services. And we have to define a appropriate set of applications for Singapore. And these are the working groups actually that are working currently related to data acquisition, simulation, information modeling, interactive modeling, visualization. I myself involved, or I'm heading 2 of these working groups on the issue of generation of 3D, automated generation of 3D city models, and on the issue of 4D city models, how to update automatically city models. And all of these working groups, if you have the time to read through, are somehow related to geomatics also. Geomatics has an input almost in all of them. This is a view on the Asia Value Lab as it is planned. It's currently being set up. It contains 3 times 82 inches touch display wall, 4 times 50 inches mobile touch tables, and hopefully a system with either 3x3 or 4x4 video systems, wall systems, possibly. I'm working on this issue. I have not convinced my colleagues yet that we need stereo display, but I hope I can. So this is a fairly large and expensive, you talk about $1 million US for such a system. We have a similar system in Switzerland, so the plan is to connect both systems, that we can work interactively in Switzerland as well as in Singapore. This is currently, as I speak, being set up in Singapore. Now, we are getting concrete here. This is a list of requested data. That data that is requested from the other research modules. You remember the stock and flow modules that I've mentioned before. They need all this data. Again, I'm not going through it. Some of the data is available already. Some of the data you can get in Singapore. Some of the data you have to buy. Lots of the data we will have to generate ourselves. Okay? So this is geomatics data. I think I skip about this one, about reality-based modeling for emergency management, because once you have this data, like 3D city models, very precise digital terrain model, then you can start modeling, you can start doing simulations. Fujin Murai has shown the case of tsunami, earthquake and tsunami. I don't know if there was any modeling before of possible events in Japan. Any 3D computer modeling, yes, they did it, okay, but it didn't help because the assumption was still not sufficient, right? Okay, so this data can be used for modeling, but I skip over it because Professor Murai has addressed the issue of natural disaster. And we all know what has happened lately in the past few years in many parts of the world, and how important geomatic data has become in form of satellite images, for instance, in form of aerial images. This is also quite interesting. A tornado in Oklahoma, you see the path of the tornado is shown in an aerial image, or satellite image even here, very precisely, very sharp. I was surprised to see that a tornado leaves such a sharp path with very sharp borders. This is a magnification to destruction here. So you're all familiar with this kind of imagery, so I would like to skip over it. And just would like to mention that we are dealing with models here. We are dealing with 3D models. And most of us are concerned with geometry, but with geometry only. But I would like to remind you that if you put it on a GIS, topology is as important. Semantics is becoming more and more important. When I talk to my colleagues from city planning and architecture, they are not so much interested in geometry. Semantics is much more important for them. Semantics, how many people are living in a house? What are the number of rooms? What is the material that a house is built from? How old is it? What is the price of the house, the value of it, and so forth. So these are all things we have to be, or we better should be concerned as well. And appearance is a new terminology for texture. Okay, they call it appearance. And of course, with texture, you can create a lot of problems. So these models are used for the analysis of life cycles of building stocks and flows. So we know about the imaging platforms from satellites, aerial images going down to model helicopters, for instance, UAVs and terrestrial images. And in summary, I would like to say about satellite images, we can nowadays georeference satellite images consistently with subpixel accuracy in planimetry and height. So the georeferencing to me is not a problem really anymore. Okay, this is a solved problem, and we have shown this with many different sensors. Producing digital terrain models, we are somewhere between, when we do it fully automatically, we are somewhere between 1 and 5 pixels, depending on factors like terrain, land use, image texture, and image quality. These are the good news, but the bad news is still that the availability is very often not good, sometimes because of cloud coverage. Here's a hope for improved availability in the future. The costs are still high, sometimes too high. We hope for lower costs in the future. And of big concern is sometimes the low image quality, as we see it, or have seen it, like with Arlos Prism, for instance, coming from calibration problems, timing, weather, atmospheric effects, clouds. And also good commercial software, especially for image matching and object extraction, is still lacking. We have for georeferencing, but not for the other tasks. So, okay. This is just an example that shows you, that visualize you one of my statements about image quality. We have here our campus in Switzerland from an aerial image downsampled to 2.5 meter. The same pixel size as a prism image. And you can appreciate and see the difference in quality right away. So basing a decision about a satellite image on pixel size is not sufficient. Pixel size should not be the sole parameter, because here again, you have the same pixel size, but much difference in quality. So use NTF, for instance. If you use NTF function, then you get a better idea about the image quality. Pixel size is not sufficient. I have an example from Singapore about georeferencing, where we work now with satellite images in 2 areas of Bungo and Little India and Keelong, and we have used WV2 Iconos and WV2 stereo images, and we have used RBFs, racial polynomial functions. Now, if we only use RPCs, we end up, in this case, in Bungo, with about 3 meter or 4 meter accuracy, which is not enough for us. Now, if we do RPCs with bias correction using only one control point, then it drops down to subpixel accuracy to these values, okay, which are subpixel or 1 pixel subpixel accuracy. And the same happens with Iconos images in the area of Little India, Geelong, for instance. We start without any corrections, just using RPCs at a level of up to 5 meter, and then this drops down to 0.8, 0.9, 0.6 meter, so again subpixel accuracy. This is something which we experience all the time with all the sensors, all the satellite images that we are using consistently. Okay, RPCs are usually not sufficient. You have to use them in a bias corrected form, or you have to use a strict model. Now, satellite images from space. Here